I'll be covering the Riemann sum and integration. The Riemann sum is a method of approximating the area under the curve, and it is done by using the sum of the areas of evenly width rectangles. However, to determine the height of these rectangles to actually calculate the area, there are three main methods, which I will illustrate using this table. The first method is the left endpoint method. So given some subinterval inside our graph, for example x equals 2 to x equals 4, we would use the left endpoint of this subinterval to determine our height, specifically the function value at x equals 2, or f of 2. Likewise, for the right endpoint method, on the same interval, we would instead use f of 4 for our height because that's the right endpoint of this subinterval, and the midpoint is just the middle of this subinterval, or f of 3. Mathematically, this is our Riemann sum formula, and although it looks a little confusing, all it is that n is the number of rectangles that we use to approximate the area, f of c sub I is the height of the rectangle, and delta x sub I is the width of our rectangle. Now, if you were actually going to try and use rectangles to approximate the area under the curve, you would notice that the bigger n is, or the more rectangles you use, the more precise your approximation. Because of this, although we can't substitute infinity directly into our expression, we can take the limit as n, or the number of rectangles, approaches infinity to get an exact area. And because this was very cumbersome to write for mathematicians, we invented the integral sign to basically say the same thing. And you'll be using it a lot in AP Calc BC. Thank you guys for watching.